大家好，我叫乔维斯. Hello, I am Tays from Bradford, and today I am going to be talking about how to read a scientific paper. A lot of people send me messages saying that they've seen a paper that I posted and saw a paper that I sent them in the messages, and they say that they read it, but it is not enough to read it. You have to apply a very particular kind of methodology. You have to be very systematic, and you have to use metacognition, or thinking about how you think when it comes to reading these papers. Now, the paper that I will be using as an example is from Lee Smolin and is named How Far Are We from the Quantum Theory of Gravity? Now, I will be using DeepSeek. I will not be using ChatGPT, Claude, or Gronk because they are affiliated with nefarious entities. So we will be using Zhongguo's DeepSeek. Now, here's the prompt that I used with this paper. I need to say that you can upload papers into DeepSeek. And here's the prompt. An elaborate and verified exposition of this paper is a must. It must be grounded in the following principles: a rigorous mathematical foundation rooted in LaTeX, a highly technical and demanding pedagogical approach, a commitment to conceptual depth over simplification, a thorough inclusion of historical context, and an unwavering pursuit of clarity within complexity. Now, here's the more important part, the format. The format has a color-coded system in which red represents objectives and findings, orange represents key terms and acronyms, yellow represents past work and theoretical background, blue represents the materials, experimental parameters, and the equations that are used in the paper, purple represents future work and implications, green represents the references that must be checked, and black represents a rigorous, comprehensive SWOT analysis. And this is an acronym that stands for strengths, weaknesses, opportunities, and threats. And analysis is used to thoroughly evaluate both its empirical and inferential feasibility. The analysis will delve into every aspect of the presented content and scrutinizing its foundational data, logical deductions, and the potential impact of this paper. Now, I already put the prompt in and I put the paper in DeepSeek. So just to kind of skim over some things really quickly, when it comes to the primary objective of this paper is to perform a systematic, objective, and technically grounded evaluation of the progress made by quantum gravity. Some of its core findings include the notion that both loop quantum gravity and string theory have achieved some profound non-trivial results. The two theories have very divergent paths that are a collection of background dependent theories and unification interactions. When it comes to the key terms and acronyms, some of the key terms are quantum gravity, which is physical theory that unifies the principles of quantum mechanics and general relativity. Background independence, which is a fundamental principle inherited from general relativity that states that no fixed non-dynamical space-time geometry is used in the formation of a theory. So that basically states that the geometry itself is dynamical, and this is very important for quantum gravity. And another key term acronym is ADS-CFT correspondence, which is a proposed duality between a gravitational theory and anti-de Sitter space and a conformal field theory. Yes, I know a lot of these terms are advanced, but you're going to have to look up some of these terms and do some of the work yourself. Some of the past work and theoretical background is based on perturbative quantum general relativity, in which there are certain flat Minkowski spaces that leads to a non-renormalizable theory, and these divergences can't be absorbed, and this hurts quantum gravity. Some of the materials and equations used are based off of the area and volume of quantization, black hole entropy, and a modified dispersion relation. Some of the future work and implications deal with the low energy limit, perturbative scattering, vacuum selection, and conjecture proof. Some of the references that need to be checked are based off of Ashkatar, variables, Strominger, Vafa, Mendelsina, and physicists such as this. Now, here's where it gets really important, an SWOT analysis. Now, some of the strengths of the paper is that it directly addresses background independence from the quantization of general relativity and Lorentz invariance violation and things like that. One of the weaknesses is there is no complete proof that general relativity emerges in the low energy regime. Another weakness is that it has a limited capacity to develop certain frameworks dealing with perturbative scattering. Some of the opportunities is that it does acknowledge that certain near-term experiments dealing with Lorentz invariance violation can be done with certain experiments that we have now. But one of the threats is that this stuff isn't as empirically falsifiable as it should be. And it has certain theoretical inconsistencies that fail to explain certain things in the low energy limit. So there are some other prompts that need to be used that I am going to kind of show here, and you can pause and look at them. These are prompts that deal with critiquing the last prompt. You have to critique your prompts. You just can't accept the first one at face value. And there are prompts to look for certain things dealing with knowledge gaps, such as implementation gaps, contextual gaps, empirical gaps, methodological gaps, data gaps, and things such as this. So there are two other prompts that I use after the initial prompt, dealing with critiquing the initial prompt, and basically another prompt that looks for various gaps, contextual gaps, implementation gaps, and theoretical gaps. So you have to do a kind of negative prompting to make sure that you just don't accept things in face value. But this is how you read a scientific paper.